How caves form. Solution caves form in limestone and other softer rocks from water. Think of a solution cave system as a series of pipes under the ground. After a rain, the water will seep into the ground and percolate beneath the surface. Percolate means slow-moving water through soil and rock. Water seeps through cracks in rock. Underground stream carves into rock. Large cave system develops. Solution cave formation. The water eventually ends up in an area underground where all the cracks and crevices between the rocks and soil are already filled with water. This is called the water table. The water mixes with carbon dioxide and creates a mild acid that is able to dissolve the limestone to form cavities and passages. The large cave chambers grow when more and more limestone dissolves. Underground stream carves into rock, large cave system develops. Solution cave formation. The second part of solution cave development happens when the water table is lowered, leaving empty spaces filled with air. This is when the spectacular anatomy is formed by the deposition of calcite, a mineral contained in a limestone. The rocks and chemicals of caves. In order to have a complete understanding of how caves form, you need to understand the language of rocks and chemicals. So here are some definitions for you to think about as you go through this section. Limestone, a common rock made of calcium carbonate. Gypsum, a common colorless white or yellowish mineral used in making plaster. Calcium carbonate, a colorless or white crystalline compound occurring naturally as chalk. Calcite, a common crystalline form of calcium carbonate. Types of cave formations. Now you're going to learn about the different secondary cave formations. Speleothems is the general term for these dripstone formations, but each one also has a specific name too. Speleothems, a secondary mineral deposit formed in a cave. Column, when a stalactite and a stalagmite grow together to meet in the middle. Stalactites, type of speleothem that hangs from the ceiling of limestone caves. Stalagmites, speleothems that grow upward from the floor. Dripstone, cave decorations are formed by calcium carbonate, and this process is the exact opposite of the formation of the solution cave. Water underground contains carbon dioxide, and this gas can escape from the water. This creates another calcium solution called calcium bicarbonate. The calcium bicarbonate leaves the water and deposits on the rocks. This is how the decorations called dripstone are formed inside the cave. Speleothems. The decorative dripstone features are called speleothems from the Greek speleon for cave and them for deposit. The most familiar speleothems are stalactites and stalagmites. Stalactites hang downward from the ceiling and are formed as drop after drop of water slowly trickles through cracks in the cave roof. As each drop of water hangs from the ceiling, it loses carbon dioxide and deposits a film of calcite. Stalagmites and stalactites. Stalagmites grow upward from the floor of the cave as a result of water dripping from overhanging stalactites, which forms as dripstone. A column forms when a stalactite and a stalagmite grow until they join. More formations. A curtain of drapery formation forms on a sloped ceiling when drops of water trickle down it. Over time, a thin sheet of calcite grows downward from the ceiling and hangs in decorative folds like a drape. Sheets of calcite that are deposited on the walls or floor by flowing water are called flowstone. Rimstone dams are raised fence-like deposits of calcite on the cave floor and which form around pools of water. Halactites or corals. Halactites are curious twisted or spiraling cylinders or needles. They develop when water seeps through the ceiling so slowly that the calcite or gypsum is able to change the direction of the formation. Cave corals are also formed by slowly seeping water and are small clusters of individual knobby structures.